Today we're starting the assembly portion of an LS that we were slated to build for a Pontiac GTO. It's supposed to be a drift car. All the machine work is complete, and Andrew cleaned it this morning with Dawn soap.
Dawn soap, brush, just to make sure there's no debris.
Right. So that's done. It's been sitting outside in the sun for a couple hours, so we can't really do any measuring right now. But what we're going to do is remove the old cam bearings. I could have swore the machine shop was supposed to do that, but that's okay. We'll knock these out, and then unfortunately we don't have cam bearings today, but we can knock it out and we can actually start mocking up the bearing, the main journal clearances, and measuring the crank and things of that nature. Cleaning everything out, make sure just double checking all the measurements, and then alignment, things of that nature. So also we have a slew of parts that came in. We have these for heads. We're going to be using a set of Monster. I believe they flow.
Frankenstein.
Sorry, not Monster. Frankenstein.
Frankenstein Monster series.
Yeah. Well, I know it's a Monster in the title somewhere.
Oh, yeah.
So these are the heads. So they're already O-ringed. Pretty sweet piece. So they have a O-ring exhaust ports. I'm not exactly sure what valves it has. They look pretty big. They look like 205s or 208s.
You have
I'll grab the sheet and see. They're CNC ported. They're supposed to flow about 400, close to like 380 CFM.
Oh, really? Damn.
Yeah,
that's ridiculous.
So the LS3 heads fully CNC ported. So the thing's gonna be putting down some numbers.
Yeah.
Even naturally aspirated. The cam we're gonna run as a Brian Tooley. So those are the heads, cam, the pistons that we're gonna run are. Let's see here. These are Manley pistons and rods. Pretty sweet pieces as well. So it'll have an effective compression ratio. I believe I set it at
10
10
and a half.
Either 10. I think it was 10 and a half or 10. I had to do the math. But these are floating pins, bushed.
TSP I-beam?
I-beams, yep. They're I-beams. ARP bolts, obviously. So flat tops.
I think they're called, these bolts are L19.
L19s.
Yeah, L19 strong ones. We got Johnson link bar lifters.
They're total steel piston rings.
Got the CHE bushing link bar, or not link bar, trunnion upgrade.
So it's a pretty sweet crank. I think it's not SNK, it's K1. Yeah, K1? Yeah. Forged crank.
It's hella beefy too.
Huh?
Hella beefy.
Yeah, it is. So that's the crank. Heavily rated fillets, internal balance. I think it's a What's that? 50, what's 53?
58.
58 reluctor.
Yes.
This is a 20 something.
Oh, that one's
The 28 or whatever it is. So that's a crank or the Engine Pro. So let's see here. So we can get this pretty quick. I don't want to make this video too long. So yeah, these are the main bearing set. See here. Coated, and they're 10 under, so that's that. Set these over here. Everything has ARP bolts. Those are the rocker stands there. Billet rocker stands, so that's cool. Yeah, so that's not every single part, but that's the bulk of the parts. So
They
now
got ARP bolts for these.
Okay,
too.
nice. So there's other things, but we won't go through every single thing right now. So now what we're going to do is we are going to remove the old cam bearings. This cam bearing installation tool I've never used before, so we'll see how it goes. I think I have it set up pretty properly. Let's knock these suckers out. One thing to pay attention to is to make sure that the lip of the mandrel doesn't clip the block. You don't want the distance between the rubber and this to be greater than the distance from the face of the bearing to the housing.
Mm-hmm.
So you want to make sure that, or the bearing's not going to come out. So you're going to make sure your clearance all the way around, which we do. And lock it. All right, there's one. It's still on the rubber. Okay, there you go. Now turn it sideways. That's one bearing. So they're not
see
in
it's wearing
horrible
through a little
shape,
bit.
but it's breaking through the coating a little bit, so they need to be replaced. The bore feels good. Second bearing. How's that one look?
This one, it's got a little scratch in there. Not wearing through too bad though. It's
You know, one thing I'm worried about
not hitting like, is it copper?
Is
copper the
this, see that damage it's doing to the old bearing?
yeah.
We need to make sure, we might have to make a machine a spacer that will hug the bearing very
Tighter.
precisely,
Mm-hmm.
because this one here is kind of effing it up a little bit.
So when we put the new one
So
in,
I think what's happening is this is actually moving around the rubber. Like, so this shoulder is not quite large enough.
you can tighten this, can't you?
You can, but it's probably what we're gonna have to do.
Mm.
But I don't really like how that's kind of doing that. But you don't want to put too much outward pressure because that will increase the resistance against the wall and it's hard to get out. So this is the second bearing, third bearing, sorry. Let's see if this works any better.
Tighten more.
Yeah. The last thing I want to do is damage a new set of bearings.
Yeah.
Alright, here we go. That'll come out easy. Release it.
Let me release it real quick. That one's showing a lot of wear.
Yeah, it is. Copper showing.
Yeah.
That one. So it looks like it wore past the babbitt.
There's 3 layers?
Yeah. Copper.
I don't know.
Or, yeah, steel, copper, and babbitt. I believe that's the cocktail.
Yeah.
Or one time I had to make one of these.
The tool?
Yeah. But that's the nice thing about having a lathe.
Mm-hmm. For what motor?
Shut up.
This one's not as bad, but it's still.
Seemed pretty bad. Seems better. It's seen better days.
Yeah. No copper showing though. No chipping. Oh, actually, there's a little bit of
Chipping.
on the inside. Yeah, they're just falling apart. Yeah, I see.
We're not going to use this method for installing. We're going to make a commander for it that fits perfectly against the new bearing surface, and we'll polish it so the bearings aren't damaged at all.
Is that it? Or is it one more?
Which one? Last one.
Yeah.
So I think overall this tool worked. It works really well for removing them, but I wouldn't use it to install them. And the reason why I wouldn't use it to install them is the fact that
Grab the ones.
this one's good.
That one's the one we just.
That one's gonna act up too.
Yeah, that one's worse.
So there's a chamfer that's on these segments here. I don't know if you can see. And it's really this one has a heavy chamfer, and that one has a light chamfer. So I think the bearing is actually moving around like this. Even with it expanded out, it still has an opportunity to the plastic to compress on one side and kind of move around a little bit. So I would not use this for installation moving forward.
What brand is this?
It's a performance tool. So what we're going to do is we are going to machine a mandrel that is not without segments. That way there's no breaks, and the chamfer won't be very heavy, and it's going to sit in this bore with a clearance of about 2/1000 of an inch. That way when we actually put it in, nothing moves around. So we'll have to make that up, and then that'll be part of the next video.
Yeah.
So we'll have to clean the block again, get all the chips out from the removal of what we just did,
Mm-hmm.
and then make a mandrel, put new bearings in it. We'll order them tonight, and then we will start doing the clearance checks for all the bearings. So for now, I think that's it. Next video, mandrel, cam bearing installation, measurements on the bores, crank, the main journals, and rods.
Cool.
And skirts. All right, that's it for today.